It's time for the last section of Chapter 5. Huzzah! Very excited about this. Now, we've already seen this particular topic before. I felt it was important enough to mention in earlier sections, but it's back here. It's the multiplication rule of counting. It says if a task consists of a sequence of choices in which there are P selections for the first choice, Q selections for the second, and so on, then all you have to do to figure out the number of selections possible is P times Q times R, and so on. All right, so for example, a wedding meal has a selection of 4 different appetizer platters, 3 different entrees, and 2 different desserts. How many different meals are possible? So to find this, you multiply, oops, in my case, fight with your machine. All right, 4 times 3 times 2, which would be 8 times 3, which is 24, or 12 times 2, which is 24. Or you could find it with Excel if you're not quick on your numbers multiplying, like I am. All right, credit card PIN numbers are 4 digits. How many different PIN numbers are there? Okay, so with the digits, there are 10 digits. 0, let me just write them out. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Just like a 10-sided die when we run into those. So for the first, you have, let me put it this way. You have 4 slots you need to fill, right? So you need to fill the first slot, then the second slot, then the third slot, and then the fourth slot. So how many different options are there available? Well, it's 10 times 10 times 10 times, 10, which would be 1, 1, 2, 3, 4. If you remember back from grade school, when you multiply 10 times itself a certain number of times, all you have to do is count the zeros, and you've got it. So there's 4 zeros, so it's 10,000. So there's 10,000 different possible pins. All right, done with that. By the way, that's the same way you can figure out how many different license plates are possible too. Just remember, with license plates, there's 26 letters and 10 numbers. All right, so if n is greater than or equal to 0, it's an integer. The factorial symbol, n factorial, an exclamation point, is defined as follows. N factorial is n times n minus 1 times n minus 2, and so on, all the way until you get down to 3, 2, and 1. By definition, 0 factorial is 1, and 1 factorial is 1. I don't want to get into why it is, but there's some mathematical reasons for why that has to be the case. Just trust me that 0 factorial is 1. All right, so there are 7 toddlers in daycare. How many different ways can there be placed in a single row to walk on the playground? Okay, so let's think about this for just a second. Hold on one moment. There. I wanted to do something here. All right, so there's 4 kids, 5 kids, 6 kids, 7 kids. Now for the first kid, there's 7 options, right? Because for the first kid, you've got, the first kid in row, I should say, 7 different choices. But once a kid is placed, then there's only 6 options, and then 5 options, and then 4 options, 3, 2, 1, right? The last kid in line, there's only 1 kid left to be that spot, right? So there's only 1 choice. Once you've got a kid placed in the first spot, then there's 6 kids that you have to choose for the second spot, and so on. So in other words, the answer is 7 factorial. Right? And you can find factorials with Excel. Let me show you how. It's actually quite simple. You just type equals 7. Equals fact. Sorry. 7. There you go. Fact stands for factorial. There you go. It's 5040. Cool, huh? So that means back here, there's 5040 different 5,040 different ways that 7 kids could line up. Amazing, isn't it? All right, that's factorial. And it's kind of interesting because a lot of times factorial shows up on standardized tests like SATs and ACTs, and students have no idea what it is, but it's actually quite simple. It just means you multiply 7 times 6 times 5 times 4 times 3, and then so on until you get to 1. All right, that's that. Next time we'll start with permutations, which we've actually seen before in a previous video.